Hello everyone. My name is Varga. I'm a PANTHEON fellow at PANTHEON Technologies. I'm here to talk about you briefly about the 10 years that has been OpenDaylight and essentially where we've come with Linux Foundation and open source and networks and everything all that in the past 10 years. And it's been an interesting ride, to say the least. Okay, so on the agenda, I have some introductions, some preludes, because all of this software-defined networking and all this started a long time ago, and it just took so long to actually snowball and gather momentum that it's important to understand that OpenFlow didn't start things, it just gathered some critical mass. So I'll go into some of the details of the individual industries and where we were, say, 15 years ago and there. Then I'll jump into the early days, so 2013 to 2015, where we essentially organized all this and had all the attention of the media and all that. Then we transitioned obviously to run-of-the-mill, where we mostly have figured out things. And then obviously came a downturn where a lot of SDN companies went out of business. There were a ton of things that occurred, and they had a direct impact on OpenDaylight and other projects as well. And then we'll get back into where we are, how we stabilize the community, and how we plan to get back into the ring. So, OpenDaylight was, and this is a direct quote from the initial announcement, it was created as an open source community and a meritocracy, which is to say that contributions matter. It's not platinum levels, it's really about open source values and contributors govern. It was launched, I think, is the first collaborative project under Elephant umbrella. If not first, it was second major. RP just stepped out, he could have corrected me there. And the scope was essentially everything. Everything SDN, everything that has SDN or SDN implications is part of the scope for OpenDaylight. We need to work, whoever wants to contribute it, we need to figure out how to work with them, bring them, embrace them in open source community, and build it up. Which is quite a thing to say when nobody really knew what SDN really was. In certain ways, it's still true to these days, because essentially SDN is many things to many people. As for priorities, our core concept was, well, focus follows interest, and interest is measured in terms of contributors. So competing projects are okay. It is okay to abandon projects if they don't have contributors. And there's no one to tell anybody to work on something and you have to work on this. There's no armchair architecture or anything. There is a TSC which takes care of the run-of-the-mill operations of the entire project, which became seeded by Platinum members because essentially we needed to start up the community from scratch, from different competing code bases, from different competing use cases and all that. And that was the only way we could make it work. But once we had bootstrapped it, things like, I want to build an OpenFlow plugin, you go wild, and as soon as that project got created and approved, you were sovereign. So nobody could tell you how can you build it, when, and what your deliverables are, what's your timeline, yada, yada, yada. So in this regard, it was a very much disaggregated project. Contributors had to commit to, yeah, we're going to do this. And it wasn't like somebody can tell them, you have to do that in half a year, and you have to deliver this documentation hard on this project, deliver this container or whatever. So that was really the idea of open source and how communities should work. So built from grassroots, there is some oversight, but it's completely open. And the accountability is there. So software-defined networking. It really got coined when OpenFlow kind of took over the term and said, well, we have to desegregate the control plane because, yeah, that's what really the switches, the cost of switches is really the control plane. So let's split off the forwarding hardware and let's define a protocol where a centralized point can decide who's doing what and completely control the data plane. Well, yes, that works for campus, data center, layer 2, if you buy OpenFlow switches. But yeah, we have other networks, right? We have service providers who have MPLS cores, who have access layer, who have edge and services layers, and all these things run in multiple data centers. There's high availability, there's compliance issues, there's 50 milliseconds path restoration, which is a must, because if you can't restore it that quickly, then your voice services are not working. And yeah, so it really became rapidly obvious that nobody really has the answer of what SDN is. How do you do SDN? But there actually were many different partial solutions, pieces of the puzzle, and individual use cases where you took the SDN approach, where you program your network to do something, and it fulfills your need. One example I have here from 2004, actually. I used to work at the telco, and I was in business support system something, and we had I think it was, 3 engineers who were responsible for configuring our internal network. One of them figured out that there is this cool thing, which is KD console, which has SSH integration. And he spent 2 months just building up upstreams. And in 2004, his configuration of switches was, as the end, I will just run this script, it's going to log in there, it's going to do a transformation of the configuration, and it's done in 1 minute. It was 30,000 lines of configuration, so it took some time, but still it worked. So, and that's one way of doing things. So, then the other part is obviously how do you do this? Is it an NMS where engineering an end-to-end path and committing all the resources takes 3 months and a SP level project, and then you forget about it and why it was turned out? Or is it really a real-time optimization problem where you essentially are delivering services and something is computing things and getting you to, essentially solutions? So it was very fluent, and we didn't really know what design are we taking into account.
So, preludes. So this had a prelude very long time ago. Back in 2000 or 2001, I don't remember, there was a call between service providers and IETF, and the service providers came in and said, well, you define everything that is internet, and for management, we have SNMP. You cannot use SNMP to configure things. You cannot use it to really pull things because it doesn't scale. It's binary, nobody understands it. It's stateless, please fix this. So it took 6 years for IETF to come up with the first proposal, which was netconf, which provided a direct path from SNMP. It was XML-based, human-readable, based on SSH or TLS or whatever, and essentially fixed all the perceived flaws. That was one track. The other track, in Stanford, OpenFlow was defined to essentially solve a completely different problem that actually a campus can have, and they perceived it as a problem that needs solving. And then in 2010, actually, IETF defined a competing solution to the OpenFlow problem, again, based on XML, and that's FORCES, which stands for Forwarding and Control Element Separation Protocol. I think it was a long time ago. And then, obviously, Yang was defined as the data definition language because, as we just discussed, when you have just YAML to have your configuration data, it doesn't tell you anything. So Yang, again, solves the data definition problem where you have clear definition of what the configuration means, what is the intent of that. And then all that came together, and in 2012, two major things really happened, which was OpenFlow 1.3, which finally meant that OpenFlow could be used in production, because 1.0, if you try to do anything with it, you'd really quickly find out that, yeah, you can't really do anything. And then VMware acquired Nicira for $1 billion. And that meant everybody screaming, and everybody wanted to be the next startup who gets acquired, and SDN has to be the thing that we get acquired on for another cool $1 billion. Actually, at the end of 2012, IBM started pushing for saying that, well, an OpenFlow controller and really an SDN controller should be something that is off the shelf. Just like for an IDE, you have Eclipse, and you can, well, design your code there. You should have a standard platform for SDN controllers, and that's where essentially OpenDaylight got started. So, yeah. So I got engaged with OpenDaylight in, I think it was something like first week of January of 2013, when it was clear that this is happening. There are actually two competing code bases which will be used as the seed code. One was coming from Cisco, one was coming from Big Switch, and there were all these things trying to figure out how do we start with this, how are we going to code drop it, where is how it's going, how the infrastructure will work, who is going to take care of that, and all that. And then on March the 22nd, the initial code drop of the Cisco code got dropped into a Linux Foundation private repository. And yeah, 2 weeks later, there was the first announcement of the OpenDaylight as a community with target to do everything SDN. So from there, it was quite an interesting ride, because everything happened essentially on the go, because we needed to figure out our governance, needed to get to know all our peers, figure out what is it that we're going to deliver in the first release, how are we going to structure documentation, testing, all that goes into setup, which you don't really find unless you're on a particular project from the get-go, because usually you come in as a later contributor, and these things are most of the time figured out and work well enough. So based on that, there was a first mini-summit in New Orleans in September 2013, where essentially the basics of the first release were defined. And the idea was that we really have three targets, which is a base edition, which is just OpenFlow. And it's really just not even a learning switch. It's just something to get you started, and that's the baseline controller. Plus, obviously, since the initial contribution actually included a netconf server, a complete management configuration management layer, and something else I always forget. Oh, the MDSL, obviously. So those were packaged inside the base edition, and then we had service provider edition, which was all this plus BGP and PSAP and things that you really need when you want to integrate with an SP network. So BGP LS to ingest the state of the core and all those forwarding things and all that, plus PSAP to actually control your layer 3 MPLS tunnels and get those computations going. And then there was virtualization, which was really about integrating with network slicing and OpenStack primarily. So there were, I think, 3 competing applications which did network slicing and scheduling flows on top of an OpenFlow network. So based on that, on second try, actually, we got the first Hydrogen release in February 2014, and there was a huge flux. The first release was like, it took 12 hours of an IRC session to get everything released, because 15 minutes before the actual release process started, Garrett mismerged one of our late-coming bug fixes. So it actually created a contribution, regression, which the testing suite didn't find. And we found it only after we tried to integrate the release. So it took something like 2 hours to figure out and fix. And then obviously everybody had to be on IRC for those. I think it was like 15 projects for each of those projects, because everybody is responsible for their own releases to do their release thing, which was highly manual, very error prone. So it was a nightmare, but we got it done. And we said, okay, we need so much things to change. Things need to be automated. We have to change the packaging, figure out how to have distributed documentation, because we actually had none, and all those things. So it was really a year of a lot of changes, which at the end of the day defined our scope for next, I think, 3 years, until we executed each and every one of those changes as we also built up our use cases. And I'll show about it. I'll show you more about it in next slides. There was another thing that obviously Red Hat came in and started taking over the network virtualization use cases and the entire stack, which was very important because they gave it a structure, defined the CSIT, and drove essentially the entire use case stack and solved a lot of the issues that really were integration issues and the low-level plugins didn't really care about. Then there was an ITF shootout where ITF suddenly realized that yes, there is SDN, and yes, it is happening, and yeah, we have a couple of protocols which are contenders, and what do we do about them? And there was a huge shootout between essentially forces, which was the control plane separation thing, and netconf, which was really driving management only, but it was shown by major contributors that essentially netconf could be used also as a control plane protocol, and it's just less efficient, and we can always fix that, but the core basics are there. And the entire shootout ended up with netconf Yang winning. And the big reason behind that was it was human readable, and there was an open source implementation. You could download any day, and it was called OpenDaylight. Forces had only one implementation, which was proprietary. You couldn't get even a shareware or tryout version of it anywhere. So, and that's where essentially all the standardization in IETF converged and said, well, okay, if we are going to define management plane and control plane operations, we will use Yang to do that and use netconf to drive it into network. And that push essentially continues to this day. There's a huge uptake of new models. So sometime after that, in October, we had our second release, which was essentially the first non-alpha release, which we kind of said, okay, everything works as far as we can tell. And we are reasonably feature complete. And then the deployment feedback came in and said, well, it doesn't really work as soon as you try to scale it up or try to do anything real with it. So we came back and said, okay, so we need to adjust. We need to spend actually a full release cycle where we do not care about features, but we care about testing, documentation, and making sure those features are as solid as can be. By this time, we kind of figured out, and this overlaps into 2015, that we really want to be doing something like 2 releases each year, and have that first release somewhere in spring, and then have the second release somewhere in autumn. As things go, if you're stabilizing things, it's going to take longer than you think. So in June, finally, we originally shooted for March, I think, or April. It took actually 2 months longer to actually integrate all the changes and sign off on all the new tests that we've created so we could actually ship it and didn't feel bad about it, that we knew about bugs and shipped anyway. We also figured out our governance and how it's going to work, all the representation stuff, and prepare the transition from having appointed members of the TSC and essentially having companies dictate to how our elections will work, who will be eligible to run and vote, and how those votes will work, for what term, and how all this will work. And we kind of said, okay, so it's going to take us, this is what we want it to look like. There are certain parameters that we can, so there's a framework, and there are parameters that we plug into it, like number of TSC seats, how many are representatives of individual projects, how many are committers at large, and similar things. The other part was that our day-to-day operations finally started to work. So we had all the verification there. There wasn't like we have 15 projects building and anybody can break anybody just by merging something in wrong order. Most of that verification we got down. It was very costly. It took us, well, 2 years to build those pipelines, but we were finally there. And we started to get real deployment feedback, and some use cases actually started to work. So that was very, very, very happy time to actually see all this to come together. And essentially, we started to get used to development testing forums, which were huge events with many breakout sessions, hackathons, and well, those design sessions were always broken up because it took like 2, 3, 4 hours to just to get together and figure out what the next steps are. But it was critical in getting the use cases and those distributed communities to actually deliver the value. So by 2016, we were essentially run-of-the-mill. So we knew our release cadence, we knew our priorities, we had most of the projects in. And we essentially, I think it was in October 2016, when we held our elections, out of which we had a TSC which did not have any appointed members, so it was fully community-driven. But there were things that were not quite okay, because individual member companies started to get acquired. Suddenly, some people stopped communicating, participating, and we didn't know what was going on. And while all this build-up was still happening and there were new use cases coming on board, there were some use cases which suddenly had contributors who were not communicating. And there were cutbacks even on things that were committed previously that suddenly didn't work. So suddenly we had this weird sense that, okay, so not everything is going as planned, or not everything is rosy. So I forgot to mention that in 2015, we switched to Karaf as our OSGI container, because before then, we had something completely homegrown, and which happened to work, but nobody could tell anybody why it's built the way it is. It just worked, and you shouldn't really touch it and upgrade components and anything. It just worked, okay? So then we came and, well, Karaf 4 came out, and we needed to migrate, and we suddenly realized we have a huge amount of technical debt that needs to be taken care of. And yeah, so if you take a look at what it was, this was Boron. I think that was released in September 2016. And there's a lot of plugins, and so the dark things are just new things that have appeared in that release. In the middle, that's essentially the core application components that were part of the platform. Then there was actually still is the service abstraction layer, which essentially bound all those individual plugins together. And all those small rectangles down, those are protocol plugins. So we had something like 15 of those. So overall, a big picture, so a lot of things coming in. Then in 2017, a ton of things changed. First of all, ONAP got announced in February, and suddenly there was a cool new kid in town which was doing orchestration. And if anybody can tell me what's the difference between, well, if you have a controller and an orchestrator, who's doing what? Where's the clear delineation of who's doing what? Nobody could tell me then, nobody can tell me now. Because, yeah, they overlap. In different deployments, they will have different functions, but yeah, orchestrator sits on top of a controller. Because mostly the controller should be a single-site thing which reacts to immediate needs, whereas the orchestrator is concerned with the more reconfiguration things and kind of planning ahead, multiple days, across data centers, and all that. Well, that separation didn't exist in 2013. That's something that came about with defining ONAP. And obviously, we saw a fallout from that because a lot of member companies which were contributing to OpenDaylight suddenly switched to, yeah, the ONAP architecture has different modeling, it's more aligned with what we are doing, and suddenly a large chunk of our contributors moved not somewhere else within LFN, but to a different project. So we kind of felt that pain. But it was still all good because, yeah, we are aligned and it's still the same house. We also got a new executive director, so Neil Ajak stepped down, and filler up, started to fill that role as an interim for essentially a year, because by now LFN projects started to crop up left and right. Things like open governance became a thing. And the member companies started to push back. I remember one conversation which went like, well, why should I be paying $1 million to sit on the TSC for 4 projects if I'm also contributing? I would much rather spend three of those 4 million to pay for developers and get stuff done instead of, well, paying for something. So that actually led to a recharter at the end of 2017, where all those individual projects got merged into LFN and all that lawyer magic happened. But, and also obviously Cisco pulled out, announced that it no longer will ship Cisco Daylight or whatever they called it, CD something, I don't remember. And we actually had to call some projects from our simultaneous release because the contributors were not there. They needed to update the code base, and given the distributed nature, we couldn't do that for them. So yeah. And then the 2018 crunch continued, because at the beginning of 2018, Red Hat came in and said, well, yeah, we will be going away, but luckily, not like Cisco pulled out quite quickly. Well, actually, Cisco took something like 3 months to scale down and exit or something like that. Red Hat came in and said, well, we will be disengaging after we do the TOIs and training and whatnot, but we are exiting. So we, as a community, picked up some of the slack, but most notably, the network virtualization bits were not handed over and kind of lost their structured leader, well, structured and the tribal knowledge of how things work, how CSID works, for example, what migrations are ongoing, and what needs to be done. So it kind of threw a wrench there. And yeah, after that, we actually had the first mass archival of projects, when we archived something like 15 projects, because we said, well, nobody's actually contributing them. They're not well documented, and there don't seem to be any users of them, so we can't maintain them. So we either push back our releases and try to make it work outside of our usual framework, or we just drop them. So we chose to drop them, and turns out it took something like 4 years for some users to appear and ask about those projects, at which point all we could say, yeah, we can bring it back if you are willing to pay for that or contribute the resources, but it's going to be a lot of work because a lot of things changed. But we kind of said, well, it's what it is. I mean, if you don't have users and contributors, you cannot be delivering something and spending resources on that. In that year also, InnoSight went out of business quite quickly, which was interesting because they were sponsoring quite a bit of our infrastructure work, especially around data store and documentation about AAA and whatnot. So that was quite hurtful. But yeah, both of those cases, Lumina, which essentially was the leftover from Brocade, picked up most of the slack, and we kind of trudged on and said, well, okay. We recognize suddenly that we have a lot of technical debt, which was not addressed, and things seem to work, but we cannot really evolve the system unless we make drastic cuts. Releases went just fine. So at the end of the day, the end deliverables we delivered on time and on quality. The problem was that on our mailing lists, some things stopped working. So there were users who asked questions and suddenly nobody answered, or answered 3 months later. So that became quite problematic. And the trend continued. So now we're in our third year. And in 2019, we actually start slipping our internal deadlines for simultaneous release. So I think the testing deadline for Neon was meant to complete in December and actually completed in February. So there was trouble brewing there, but fortunately at that time we finished flushing out the technical debt from our kernel projects, and we kind of stabilized the overall thing of what the features are going to be. Unfortunately, new features now were mostly improvements to existing use cases here and there, not something you can really market about because it's not a cool new feature, it's just an improvement and things start to work better and more reliably. This also meant that the pressure on our end user applications like NetVert and Nemo and all those started to mount because essentially they were the only ones that needed to fix their migrations, their technical debt, and they actually didn't have all the developers. So we didn't realize that then, but we kind of knew that, okay, we know the set of problems that need to be solved, and we can kind of hedge it and not complete all those migrations, and we'll wait for a year for those things to get fixed, and then we'll move on. And with that, we essentially shipped Sodium in September and said, well, okay, we've got something like a year to get most of the things done. So contributor-wise, it seems that going into 2020, we knew the basic feature set. It was essentially NetVert plus some of the SP use cases, plus Transport PC, which is really about SP, and netconfig as the core feature. And we realized that, yeah, in 2020, most of the features we delivered were centered around netconfig. There was something like 2 or 3 improvements to BGP SEP. There were 0 major improvements to NetVert, for example, or OpenFlow, because it was what it was, it worked. And there were a few contributors, so it was mostly like little tweaks, maybe a bug fix or 2, to just keep the ball rolling. And it seemed that this is going to work quite well up until August, I think, 25th or thereabout, when suddenly Lumina went out of business, essentially over weekend or something like that, which essentially removed something like 4 major contributors from our community, and created again pressure on who is going to maintain this. And again, this was testing, this was the cluster data store, and the netconf PTL at the time. So it was problematic. We still were not quite on time with internal milestones. For example, again, the testing milestone for aluminum was 3 months late because we delivered it in August instead of sometime in May or thereabout. But again, releases were on time because even though it was late, it was sufficiently good to pass all the gate criteria and we could release. And then just as we started to plan our 2021 releases, which we now knew that we, well, using elements to code your releases and rely on people to know the periodic table and know what the order is not going to be nice. So we've decided that the next release is going to be 2021.03 and then 09, and then we'll just use the dates. Just as we started opening that that release cycle, Ericsson came back and said, well, we are pooling all the resources. We will still use this in our product, but we will not be contributing to open source anymore. And that essentially killed NetVert as a project right there and then, because they were the last contributors to that. And it kind of started unraveling the entire stack of 4 projects that contributed to that use case. So, but fortunately, that was the end of it. And we kind of arrived at a safe place where we had been culled sufficiently to a very small and manageable set of use cases, and with sufficient number of contributors to deliver them and maintain them going forward and actually evolve them. So essentially what we boil down to is netconf, so the restconf to netconf translation, plus all the tooling that goes into all dealing with, well, yang model data, transport PCE, which is maintained by service providers, most notably Orange, but there are others, I always forget who they are, sorry. Then BGP and PSAP, obviously, but that's mostly in maintenance because, well, it works. There has been something like 3 bugs reported to it over the past 2 years. And yeah, we kind of fix them if we can. If not, we try to fix them later. Then we have OpenFlow and OVSDP. There is actually one member company who is kind of interested and still have a deployment, so they kind of maintain it, but again, nothing major going on, just maintenance. And the same thing is list flow mapping, which is a complete solution from a plugin and an application, and JSON RPC, which is a JSON RPC integration. Those are, again, just maintenance. They just work. They have all the use cases well defined, and there's no technical depth there that we know of. With that, we kind of said that, okay, these are the use cases we provide. We are not a product. We never were, although an OpenDaylight distribution was something a number of companies tried to sell, and as we've seen, faltered around it. So we are not a product. We are a set of services, libraries, maybe use cases or components of use cases, and we are open source. We maintain that. If it happens to solve a problem for you, that's great. Please use these components. If it doesn't, please try to look somewhere else. Hopefully somebody else is going to fulfill that need. If you feel like you can contribute and bring back some of those use cases, that's very welcome, but we are not going to do that because we don't have the resources to commit to that. And there's things like Nefio. There's other ways of achieving SDN in other languages, which are not Java, which are architected differently, which may be point solutions. We are not trying to take over the world and be the be-one and be-all and end-all for everything SDN anymore. We have a set of technologies. If they fit your use case, fine. If they don't, well, somebody else is going to be there. And that was a very striking realization which took many years to come to. With that, we were able to stabilize our committer and contributor base. We were able to get our releases under control again. Not quite, because we also started flushing more of the technical debt to essentially, at this point, we delivered something like 10x optimization to the Yang compiler and all that thing, and it was uncompatible, and it took 2 years to integrate and all that. But we don't have an outflow. We have a known set of use cases, and we have staff to actually support them. And we have the ecosystem to actually make sure that those contributors do not suddenly go away because there's some amount of business that is actually backing those contributions. And we actually came about and understood what we need to do to get more contributors, or hopefully make some incentives that will bring them back, which revolve around more Kubernetes integration and essentially going back to re-architecting the way we package and deliver our components and use cases to end users. Last year, we actually saw some uptick in contributors. We had some newcomers, and we kind of shuffled the contributions to actually have the core and big things and small things taken care by novices and reviewed, and there's a pipeline that starts to work, finally. And we almost made our releases on time. There were big improvements, as I said, in scalability that we were pushing out actually since 2015, some of them. And we realized that there's still more technical debt to get around, but if we can make that work, we can improve our deployment scalability 10x and integrate with Kubernetes and now have autoscale and all that. Everything that wasn't common in 2013 when you deployed on a big King server and you ran your deployment there for 5 years. Now in Kubernetes, it works kind of differently, and we need to kind of change our plugins slightly to make that work. Now coming back to this year's, we actually got a new committer this year. That's something that didn't happen in 2 years, and previously there was just one. So in the past 4 years, we had 2 new committers. Luckily, there's one this year. There's probably going to be a couple more. I think it's going to be something like 2 or 3 if my crystal ball is okay. The contributors' contributions, actually individual contributions, now are structured and there's a flow of them. It's not one contributor or one random contribution in 3 months. It's like every week, and there's a steady stream of patches, and they kind of build up to something that is reasonable. We also flushed out essentially all the technical debt we had. There's one more probably painful revision, which is going to just remove all the compatibility layers, but we are okay to kind of hold on to that for a couple of years if we have to. It doesn't affect anything really. It's just legacy code that needs to be flushed out. We shipped Argon in March, I think on time, or I think we were 2 weeks late. And it was just because our infrastructure was broken for 3 weeks, and we didn't realize. We didn't realize actually what the problem was. Once we fixed it, we actually got it working. And obviously, for Potassium, we want to make that scalability pieces work. And the idea is by the end of the year, we want to ship, actually demo an end-to-end integration of netconf, restconf control use case on Kubernetes with autoscale, hitting tens of thousands of southbound devices, which is something that is obviously interesting for ORAN and all those edge-driven cases. So yeah, that's it. And it took way longer than I expected. So any questions? Yeah.
You
So the so first of all, our site, OpenDaylight.org, needs to be completely revamped. Unfortunately, we have few marketing resources that can actually do that. I didn't mention it. We wanted to do that last year. Unfortunately, the guy I had marked for that actually moved on. And he did a prototype, and I still have the prototype on GitHub, but I know nothing about it, and I'm looking for the person who is going to pick it up. Documentation-wise, the use case documentation is mostly accurate still. Because essentially when we removed a project, we also removed all of its documentation. There are bits and pieces which are stale. If they're stale, we'll fix them. It's just that people who, the internal deployment team and everybody who has been using this for years now knows everything by heart and has their collection of what they want to do already there. Really, people who read the documentation are mostly newcomers, and it's problematic to get them engaged with mailing lists because everybody wants to be on Stack Overflow, and we don't have the resources to man Stack Overflow again. So it's problematic. But yeah, documentation should be mostly accurate. If it's not, we're going to obviously fix it. You're welcome.
Technology. So you've talked about the challenge of like having a few contributors, and just to answer this question, have you thought about like how hard is it to onboard? Do you spend any time, like how do you make it ever easier to be a first-time contributor to your project?
Yeah, that's a tough one because essentially, as we scale down the community, it's still 12 Git repos that are connected somehow. And there's ancient documentation which sits somewhere. In the meantime, we migrated the wiki once or twice. We migrated the docs from ASCII-doc to RST once. So there's bits and pieces that get left behind. And the most critical thing that we lost is the tribal knowledge. So that makes it very, very hard to essentially onboard people because if a question comes in, essentially there's a pool of, I don't know, say 10, 15 people who cover the entire stack, and they usually don't work on that particular area, so they have to go back, check, and yeah, it's kind of hard to create those incentives to make that work. That having been said, our grant plan is to redo the use case integration so that it's just turnkey Kubernetes plus an operator or whatnot, and the end user engagement becomes easy. And as it turns out, to do that, we need to clean up the technical layout, the source code layout, so that it makes much more sense. So we have just completed that for NetConf, which is the last participating project, just last week. And out of that, we have some README RSTs for now, but it's going to be MDs which are going to point out so rather than the southbound plugin being called sal netconf connector, which doesn't tell you anything, because the northbound is MD sal netconf connector, and now which one is which? One is now called a southbound, and the other one is called the northbound. And they don't have weird cross dependencies anymore. And now we can actually reason about it and throw it into, well, because MD-SAL actually is microservices, but they run in the same JVM, plus Arca clustering and all that, which you don't want. And we just need to create the API services, which it turns out are there. It's just they're muddled to reintegrate this on Kubernetes or anything that is really microservices. And once we do that, it's going to be much easier to contribute, especially fixes, because most of the time you just need a bug fix somewhere. And it's Java, so it's like trace, so you know where to look if the names are right. Thanks.